Olive says no. Oh, is it recording? Yes, it is recording. Okay, number one, we're going to graph it. So here's what I remember. It is a sine curve, and a sine curve looks like this, right? You guys agree? That's what the sine curve looks like. So, first of all, the amplitude is 3, but the period, now the period, we take this value, the frequency, we take this value, we call it B, we divide it by 2 pi. To get the period, we take 2 pi and divide it by this number 3, which tells me I've got 3 curves. I'm going to try and fit 3 curves in the normal. So if I have to fit in 3 curves, I'm going to be a little careful how I do this, right? You guys. So I'm going to go ahead and put down my X, my Y. Okay. And so I'm going to divide it into thirds. So I'm going to go pi thirds. I'm going to go 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds, and 6 pi thirds, okay? All right.
Did you put the 3 under amplitude because it is amplitude? Like up on it.
Right, so this is my amplitude here. In fact, I will highlight it for you. My amplitude comes from right there. That's my amplitude, okay? And it's a negative, but amplitude is always like kind of like a distance, so it's positive 3, okay? So let's see if I can fit this shape in here, okay? See, I got it? I want this shape. I want this shape within 0 and 2 pi, because that's my period, okay? All right, so I'm going to do this in pencil because I'm going to move it, okay? I know I'm going to move it, so I'm going to go, okay, this shape here. Oh, it's upside down, my bad. Upside down because of the negative. Okay, there's one of them. We haven't done this for a while, have we? 2 of them. 3 of them. Okay, so I've got 3 curves. 3 curves, right? Between 0 and 2 pi. Okay? So give me thumbs up if you're with me, okay? If you're following what I've got. Okay, we've done this before. Now I'm going to move it. I'm going to move it, and I like to move every important point. The important points are like, you know, zeros, max, min. So I'm going to move it, and I'm going to move it pi force forward. So I'm going to go to the right. Pi force. And I'm going to go down 2, okay? So pi force. Now pi force, if this is pi thirds, pi 6, oh boy, pi force is about there, okay? It's about 3 squares, okay? For me, it's about 3 squares. So I'm going to go over 3 squares to the right and down 2, okay? So I'm going to go over 3 squares, down 2. So this point's go here and down 2 there, okay? This point's over 3 squares, down 2, 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 and I'll let you get caught up, okay?
Does the first one say pi over 5 or pi over 3?
Pi thirds, yeah. This is... Okay, it looks something like that.
Wait, how do you know when to go up? Because didn't you say it's over 3 squares down 2?
Yeah. So if this is pi thirds, pi force is right there. That's pi force, and pi force is about 3 squares. So what I did is I like the graph paper because when I do the graph paper, then I can move things with squares. So pi force is about 3 squares. This is about pi, so this would be about pi 6, pi thirds. Okay, you guys ready for 2? I'll wait for you. And you can take a picture of mine if you want to. Must be off. This one must have to come out down here. It got sloppy. Down 2. No, down 2. Well. Oh, that's awesome. Okay. All right. Let's take a look at 2. All right, what's the equation? So first of all, we've got to ask ourselves, is it a sine or cosine? Well, it's, for me, we could probably call it a sine if we start here. We could call it a cosine if we start up here, okay? So how do you know? Are you going to, is it a roller coaster where you get on right here and go wee, or is it a water slide? It's always easier to find the max. Pretty sure the max is right there, right? You guys agree? I'm going to call it a cosine. There's 4 ways. I'm going to call it a cosine. Well, maybe a sine. I don't know. Sine's not too hard to find either. Maybe I'll call it a sine. I think I'll call it a sine. Yeah. Okay, so I'm going to call it a sine. I'm going to go y equals a sine of b times x minus h plus k. That's my formula, okay? The amplitude. Well, if this is the middle of my curve, right, then the amplitude seems like it goes up 1, 2, 3, down 3. So I think the amplitude is 3. So I'm going to go y equals a 3 sine, okay? B is the frequency, and the way you find B is it's always 2 pi divided by the curve width. And I think the curve width is from 1 to 9, I think the curve width is 8, okay? From 1 to 9, I think the curve width is 8, okay? So then my B, which is my frequency, is going to be 2 pi divided by 8, which is pi 4. So I'll put pi 4 here. Now the graph did get shifted. It got shifted over 1, right? I mean, because we started the sine curve here, right? So it did get shifted over 1. So we're going to go in x minus 1. And then the entire curve, we found the middle of the curve, got moved up 2. That is your equation. And I will help you a little bit tomorrow because I know this is hard stuff, okay? I'm not going to take the test for you, but I'd be happy to help you a little bit, okay? All right, I'm going to need some scratch paper here. All right, number 3. All right, what do you think? How about we FOIL it? Let's FOIL 3. 3, I have a sine of a minus 1, sine of a plus 1. So I'm going to multiply. I'm going to go this times this, this times this, this times this, this times this, right? So I'm going to get sine squared plus a 1 of a plus a 1 sine of a minus a 1 sine of a minus 1, okay? Identities out. I need my identities. And then these two cancel, right? And I'm left with a sine squared of a minus 1. Now, is that an identity?
Is that an identity? Minus 1 or are those lines?
That's a, what?
Yeah, oh, right up there. Yeah.
Yeah, so 1 sine of a, subtract a 1 sine of a, and they canceled, okay? Now, if I look at my identities, it's not quite. It's not quite. See how it's awfully close? Sine squared minus 1. But I'm going to do a little trick, a little math trick. If I factor out a negative 1, right? Think about this. If I factor out a negative 1, that would make this a positive 1. If I factor out a negative, that would make it a negative sine squared of a. Okay, so Little math trick. That times that is -1, and that times that is a positive sine squared. And so now 1 minus sine squared is an identity. That is my cosine squared, so I get a -1 times the cosine squared of A, which is a negative cosine squared of A, okay? Yeah, these are hard, but I'll help you. I'll give you hints tomorrow, okay? I will not do it for you, but I'll give you hints, okay? All right, we'll do 4 when you give me thumbs up, okay? Let's take a look at 4. All right. Whoop. Yes, I'll leave it for you. You guys give me... Okay, you guys ready? Okay, let's take a look at 4. All right, we've done this one before, but I don't mind doing it again. I've got a tangent of x plus a cotangent of x divided by a secant squared of x. Okay, so I think what I'm going to do is change everything to sines and cosines. I think that's going to make it easier, okay? I know tangent and cotangent. Tangent is a sine over cosine, and cotangent is a cosine over sine, okay? So I'm going to change those two. So rewrite this as a sine of x over a cosine of x plus a cosine of x over a sine of x all over a 1 over a cosine squared. Now it looks like it's much worse, right? Looks like I took something that was kind of simple and made it much, much worse. But maybe things will calm down once I do some more magic, math magic. Okay, so these two are fractions. We need to add these two fractions, which means you need a common denominator. So I'm going to multiply this by cosine over cosine. Multiply this one by sine over sine. Okay, again, I'm ignoring the bottom for right now. I'm just totally ignoring the bottom. So then I would have a common denominator of sine of x, cosine of x. That's my common denominator. And on top, on the numerator, I'll have a sine squared plus a cosine squared. Okay, I like that because that's an identity. That is, this is 1. Sine squared plus cosine squared is a 1. I like that. So then I'm going to rewrite this. For room, I'll have a 1 over a sine of x, cosine of x, all over a 1 over a cosine squared of x, right? And I think you probably know the next step, right? You're going to invert and multiply. I'll wait for you, Nina.
Where did you get the 1 from?
Great question. Sine squared plus cosine squared is equal to 1.
Oh, okay.
Yep. So now, you probably know I'm going to invert and multiply, right? You got a fraction divided by a fraction. So let's bring this down and rewrite this as a 1 over my sine of x, cosine of x times, and I flip it, right? Invert and multiply. Cosine squared of x over 1. One of these cosines cancel with one of these cosines, right? And then I'm left with a cosine of x over a sine of x. And I think I'm there, because what is cosine over sine? It is cotangent. So the moral of the story is we took something that looked like this, we made it look like this. We simplified it significantly, didn't we? Okay. I'll wait for you. All right. All right. 5. Okay, I got to solve, and it's in terms of radians. So if I need my calculator, better be in radian mode, right? I know for sure radians, and I got to solve. Okay, so number 5, 4, tangent of x plus 3 equals 0. Okay, so let's solve. Minus 3, divide by 4, right? I need the angle, so I'm going to take the tangent inverse of negative 3/4 to get my angle, okay? All right, I'm going to do that. Mode is in radian mode. Good. Quick clear that. Clear. So I'm going to go tan inverse of negative 3 divided by 4, okay? And I get a negative answer. So, and I can't use, I'm going to have to fix that negative answer, right? So technically, again, back to the unit circle, because the unit circle tells everything, right? So I go back to my unit circle. Negative 0.6 is an angle down here. Negative 0.6 is an angle here. So what we're going to do is spin it all the way around 360 degrees to make it in this exact same spot, but positive. So I take it and spin it 360 degrees, except for we're doing radians, so I'm not going to spin it 360, I'm going to spin it 2 pi, okay? So I take my answer, I've got my answer, x1 is my negative 0.643, and I'm going to add 2 pi to it to make it a positive angle. So I add 2 pi to this, I get about 5.64, okay? So my first answer is a 5.64, and that is an angle in terms of radians. We know with tangent that it always has its other answer 180 degree rotation, right? Tangent 180 degrees, 180 degrees, but not 180 because we're in radians, so I'm going to go ahead and take my answer and I'm going to subtract pi to rotate it 180 degrees, or pi radians. Same thing, just in radians. So subtract my pi. I got about a 2.5. Got that answer and a 2.5. Okay. Wow. All sorts of people, all right? Okay, moving on. Number 6. Number 6 is actually kind of easy.
Wait,
You,
can I look at it?
you sure can. Yeah. No, that's all right. Give me a thumbs up when you're ready, and then I'll do number 6.
Is that 0.643?
Yeah, I think so. Then plus 2 pi, yeah.
Yeah.
Then I added 2 pi to it to roll it around, okay? This is hard stuff, isn't it?
Yeah.
Yeah, it is. 6. This is where doing your homework would have paid off. That's okay. I'm not here to judge. I mean, you're high school kids. I can't say I always did my homework when I was your age either, okay? I always remember that I was in high school once and I didn't always do my homework either, okay? All right? 6. Okay. Cosecant squared of x minus 4 equals 0. Okay, this one's actually kind of easy because our answer is going to be on the unit circle. I'll show you why, okay? All right. Plus 4 plus 4. Cosecant squared of x equals 4. Square root it. You guys okay with that? How many answers? X squared, how many answers? 2, right? Plus or minus 2. Plus or minus 2. I got a cosecant of x equals plus or minus 2. Again, this one's not that hard. You won't mind this one. Now, that means cosecant of x equals 2 and cosecant of x equals negative 2, okay? 2 over 1, 2 over 1. Cosecant is the same thing as sine, so if I flip it to sine of x equals 1/2 and sine of x equals negative 1/2. I think those answers are on my circle, right? Sine is the y value of my point. So if I look at my circle for 1/2, it's right there, pi 6. So one answer is pi 6. And the other, there's 2 answers, 5 pi 6, right? So I've got an answer of pi 6 and 5 pi 6. Negative 1/2 is here for my y value at 11 pi 6, and the other is here at 7 pi 6. So I get these 2 answers also. I get 4 answers. So I get a 7 pi 6 and an 11 pi 6. All right, got them all. What do you think? Tell me when you're ready and we'll move on to the next one. I'd like to get this done so you guys are set for the test, right? Okay, Zoe says thumbs up. I'll wait for Chloe and Nina. All right. 7 and 8, okay? All right, 7. I have a 2 tangent square root of x equals a 3 tangent of x minus 1. So if I think about this in algebra, plain old algebra, 2x squared equals 3x minus 1, I'd bring them over and then I would factor, right? Right, just plain old algebra, right? I would bring it over and I'd factor, right? I go 2x, x, I need a minus 1 and a minus 1, right? So instead of tangents, let's just, instead of x's, we got tangents. So bring that over, bring the 1 over. So if I rewrite this, I'd have a 2 tangent square root of x minus a 3 tangent of x plus 1 equals 0. Okay? Spencer? Yes, you may. Yeah, absolutely. So then, I'm going to factor just like I factored this. Just like I factored the algebra, except for its tangents. I'll have a 2 tangent of x minus 1 and a tangent of x minus 1, because that will make my, it will make my 3. Negative 2, negative 1, negative 2 tangents, negative 1 tangents makes my negative 3. Okay. So then, I'm going to have to go, okay, 2 tangent of x minus 1 equals 0. I have many equations, right? Tangent of x minus 1 equals 0. Okay. I'll solve what tangent of x equals if I add 1 and divide by 2. Okay, you're okay with 1/2. I know, we're in pre-calc now. You guys are with me there. And then this one is just a tan of x equals 1. This is on the unit circle. I like this. This is easy. This one we're going to have to use our calculator. So 1/2 for tangent, it's not on the circle, which is kind of a bummer. It means we have to use our calculator. So, all right, I got to go tan inverse on my calculator. Tan inverse of 1/2. So we'll go tan inverse 0.5. I get an answer of 0.46. That is an angle. It doesn't seem like an angle, but it is an angle. So one angle is about 0.46. With tangents, its reference angle is 180 degrees on the other side. Its other angle, 0.46. Its other angle is over here somewhere. So I'm just going to add pi because that's, you know, we're in radians, right? So instead of adding 180, I add pi. So I add pi to that, and I get an answer about 3.6. All right. This one's on the unit circle, which I like. Tangent is on my unit circle here at pi fourths, and here at 5 pi fourths.
How can we put the line in between it?
Oh, here? Well, remember how we did our mini equations a long time ago? That's all. Remember we solved for this one, and then I solved for this one. Just show I've got my 2 mini equations, so let's solve for this one and then solve for this. Just to separate the 2 equations. It just makes it easier for us if we separate them. Chloe, I should have had you for the last couple of years, huh?
Yeah. I also just think it's like we have such short periods, it's hard to like.
It is. I know we'll be back to normal next year, but that doesn't help you guys. Okay, 8. All right, 8 is not that bad. 8 is actually pretty easy. Honest, I'm just being honest with you. 8's not that bad.
We're not gonna finish. What are we going to do about the last couple?
Well, you guys could look. It's just one. It's just the tide problem, right? When's the bell going to ring? In 1 minute? Yeah, I would take a look at the tide problem. Tangent, you're going to bring this one over and factor tangent. You'll have a tangent of x times a tangent of x minus 1 equals 0. And you'll get 0 and pi, and this one you'll get pi force and 5 pi force. I'll show this one tomorrow, right before class, okay? But it's a type problem, which we've done several times, okay?
Do you have a video up?
I don't. This was going to be my video.